In this video, we will look at connected rates of change between interrelated variables. If two variables are related, then we can imagine that when one variable changes, the other one will change correspondingly. For example, if we pump air into a balloon, we are making the volume increase. At the same time, the radius of the balloon will change as well. Likewise, when a variable changes at a certain rate, the other variable will change at a corresponding rate. This is the concept of connected rates of change. The rates of change of the variable are connected through the chain rule. dy over dt equals to dy over dx times dx over dt, where dy over dt and dx over dt are the rates of change of the variables, and they are linked by the relationship between x and y, dy dx. So for the case of the circle above, we know that a equals to pi r square, and if we know what is dr dt, let's say we know that the radius is increasing at 1 cm per second, then we can find out how fast the area is changing by using dA over dt equals to dA over dr times dr over dt, where dA over dr is 2 pi r multiplied by 1, which is equals to 2 pi r. Of course, in usual questions, the value of r will be given to us. In example 1, we are given a spherical balloon and we know that air is being pumped in at a constant rate of 10 cm³ per second. That means dV over dt equals to 10. And what we are interested to find is the rate of increase of the radius. That means we want to find out what is dr over dt. So based on this, we know that we need to form a relationship between v and r, and we can do so very easily using the geometrical formula v equals to 4/3 pi r cubed, and therefore I can find out what is dv over dr, which gives us 4 pi r square. Now I have all the essential ingredients, dv over dt, dr over dt, and dv over dr, and we can plug them into the chain rule equation. So dv over dt equals to dv over dr times dr over dt. And we know that dv over dt is 10, dv over dr is 4 pi r square, and r is given to be 5 in the question. So 4 pi times 5 square times dr over dt. And solving this equation, we will therefore get dr over dt equals to 1 over 10 pi cm per second, which is the rate of increase of the radius of the balloon. In some cases, two variables may not be directly linked to one another. For example, if we look at a sphere, we know that the volume is a function of the radius, v equals to 4/3 pi r cubed, and the surface area is another function of the radius, 4 pi r square. There is no direct relationship between the volume and the surface area, and thus we cannot directly make use of the chain rule relationship from earlier to solve for dv over dt given dA over dt, or vice versa. But we can still make use of the chain rule to determining it by using the chain rule twice. If the volume is a function of radius and the surface area is another function of the radius, then we can first write that dv over dt is equals to dv over dA times dA over dt. Next, for us to determine the relationship of dv over dA, we can apply chain rule one more time. dv over dA is the same as dv over dr times dr over dA, which is thus the same as dv over dr divided by dA over dr. Thus, we can make use of this double chain rule for us to have a relationship between dv over dt and dA over dt. And with this, we will be able to indirectly obtain dv over dt given dA over dt, or vice versa. In example 2, we have the same balloon and it is being pumped at the same rate of 10 cm cube per second. But now, instead of finding the corresponding rate of increase of radius, we want to find out the rate of increase of the surface area. So we know that dv over dt equals to 10, and what we are interested is dA over dt. So in this case, we will not be able to have a direct relationship between V and A since both of them are linked together through the radius. And thus, I have to first form V equals to 4/3 pi r cubed, which gives me dV over dr equals to 4 pi r square. And A equals to 4 pi r square, which tells me that dA over dr must be equals to 8 pi r. Thus, I can form the double chain rule relationship between V and A. dV over dt equals to dV over dA times dA over dt. And this becomes dV over dr divided by dA over dr times dA over dt. And with this, let's do a substitution. dV over dt is 10. dV over dr is 4 pi r square, which means 4 pi times 5 square. Since it is given in the question that r is 5, we get 100 pi divided by dA over dr, which is 8 pi times 5, 40 pi, times dA over dt. Thus, we can simplify this equation to get dA over dt to be equals to 400 pi over 100 pi, which is equals to 4 cm square per second. And this is the rate of increase of the surface area when the balloon is being inflated at 10 cm cube per second and the radius is 5 cm.